So some students ask me, when let the x equal to 2k pi plus y, y sine of x, okay, equal to sine of the 2k pi, and then equal to sine y. Because we know sine function has the period 2 pi, right? So that means you can throw away any multiple of the period of the sine function without changing the value of this function. So you have the sine of the 2 pi plus y equal to sine y, and then you also have the sine 2k pi plus y equal to sine y for any integer k. Okay, so this is why we can have the sine of x equal to sine of y. Some guy asked me how to solve this, how to find the value of the sine of the 17 pi over 12. For this one, if you found that 17 is too big, you may first find the reference angle of this guy. We know you can write this as the pi plus 5 pi over 12, right? Then the reference angle of the 17 pi over 12 is just the 5 pi over 12. And this angle is in the quadrant 3, right? We know 5 pi over 12 is less than the half pi, right? So pi plus the 5 pi over 12 is less than the 3 pi over 2. Then we know this angle is in the quadrant 2. So we know in the quadrant 3, since in the quadrant 3, sine function is negative, so you have the negative sine of the 5 pi over 12. And then you can split 5 pi as the 2 pi plus 3 pi. And then you can rewrite this 5 pi over 12 as the sum of two angles for which you know the exact values of the sine and cosine. And some guy asked me why 1 plus the cosine x is greater than or equal to 0. This is simple. Actually, you look at the graph of the cosine, right? And here this is 1, and here this is negative 1. So the range of the cosine function is between the negative 1 and 1, right? The range is equal to the closed interval from negative 1 to 1. So that means you always have the cosine x greater than or equal to negative 1, less than or equal to 1. Then from this inequality, you add the 1 to the both sides. You have the 1 plus cosine x is greater than or equal to 0. That's it. And some guy asked me about the 3 versions of the half angle identity for the tangent. Which one to use? It depends. Actually, I prefer the second or third because I don't need to determine the sine, right? But in this case, you have to compute both the cosine x and the sine x. And in this case, you only need to compute the cosine, but you have to determine the sine, and also you have to find the radical. Actually, this first version involves more computations, so I prefer the second and the third. Now let's begin the section 5. And in this section 5, we'll talk about the product and the sum identities. So in the last several sections, we have learned the sine, cosine of a sum and difference. We have then the half angle identity and the double angle identity for the sine, cosine, and tangent. So in this section, we talk about the product and the sum identities. And let's begin with the sine and cosine of a sum and difference. Let's list them. So we will use them to derive the product and the sum identities. So we have the sine of the A plus B equal to sine of A times cosine B and plus cosine A times sine B. Right? Let me call this identity 1. And then we have the sine of a difference, sine of A minus B. So this is equal to sine of A times cosine B minus cosine A times sine B. Let me call this identity 2. And then we have the cosine of a sum and difference. So cosine of A plus B equal to cosine A times cosine B and minus sine A times sine B. And then we have the cosine of A minus B equal to cosine A times cosine B plus sine A times sine B. So let me call this identity 3 and identity 4. So now let's add identity 1 and identity 2. So 1 plus 2. Then we have sine of A plus B plus the sine of A minus B equal to, so we have the 1 sine A times cosine B here, another sine A cosine B here. So we have the 2 times sine A cosine B. And this cosine A sine B and this negative cosine A sine B cancel. So we got the 2 times sine A times cosine B equal to sine of A plus B plus the sine of the A minus B. Now let's switch the both sides and divide both sides by 2. So we have the sine A times cosine B equal to 1/2 times sine of A plus B plus sine of A minus B. So let me call this identity 5. So this is the first identity about product and sum. It's called the product to sum identity. Okay, so this guy is called the one of the product to sum identity. Actually, we just convert this product of sine A and cosine B to the sum of the sine A plus B and the sine of A minus B. Okay, so it's called the product to sum identity. And if we subtract 2 from the 1, so 1 minus 2, let's see what we get. So sine of A plus B minus sine of A minus B on the left side. And then on the right side, this guy cancel. Cosine A times sine B minus negative cosine A sine B, we got a 2 times cosine A sine B. So we have 2 times cosine A sine B. Then we switch both sides and divide both sides by 2. We got cosine A times sine B equal to 1/2 times sine of A plus B minus sine of A minus B. And let me call this identity 6.